Hi. So what we have done up to now, we are talking about the synthesis of the combinational circuits. First, we gave some information about the general rules of synthesis, what synthesis is about. And in this frame, we define minimal functions and how we're going to find the minimal functions. These are the definitions of the minimal functions. This group here have to find the minimal function by using the prime implicants. We explained all those. This method is called Cohen-McCluskey method. Within the Cohen-McCluskey method, we have used prime implicants table. From the prime implicants table, we can find out essential prime implicants. After we have found the essential prime implicants, so this circled marks here helps us to find the essential prime implicants. Then we have to find out minimum number of prime implicants to be added to the essential prime implicants. How we are going to find the minimal number of prime implicants? In the previous example, we did it by hand. It wasn't then a systematic, there was no systematic method to find out this coverage. So in this video, we will be giving you a systematic way of finding minimal number of essential prime implicants, which covers the true min terms which are not covered by essential prime implicants. So that this video is all about this, the systematic way of it, and we're going to give an alternative, fast way of finding these minimal number of prime implicants. That is the other one. So let's go back to open board now. Open board. I've got to the switching here. Okay, here we are. Let me clear this area. This is an example now. In this example, this is a 5 variable functions. The example function that we used previously is not the same as this one. So this one, the previous one has got 4 independent variables. This one has got 5 independent variables. So it says a function like that: x1, x2, x3, x4, x5. Because of the highest number is 27, in order to represent 27 in binary, you need 5 variables. Now, by just looking these circled multiplication remark here, we can find out the essential prime implicant. This is essential prime implicant, and this is also essential prime implicant. So there are 2 essential prime implicants. Sorry. I should have done this. I should have used this one. Sorry. So clear this now. We've got, once again, 5 variable function. For this 5 variable function, this is prime implicants table. Prime implicant table. And this table, you see these marked circled marks here. This is essential prime implicant. Because of this, this is essential prime implicant. In between, you see that B, so we marked here true min terms which are covered by these essential prime implicants. Essential prime implicant, essential prime implicant. So these 2, A and C, essential prime implicants, covers 3, 7, 13, 15, 19, 23, 29, and 31 true midterms. So we mark them. So if you look at this B here, a prime implicant, this prime implicant covers 7, 15, 23, and 31. These true midterms already been covered by this prime implicant, so I ignore this B. It is not an additional prime implicant because in this line here we don't have any circled mark. So when I choose these circled marks, I do not need this prime implicant. That is the conclusion I found here at this stage. Now, the systematic method I just mentioned is related after this point. We need that. What is this? If you look at apart from the essential prime implicants, all the prime implicants are written here. And these are the true midterms which are not covered by the essential prime implicants. So that means unmarked true midterms here, 0, 1, 4, 20, 23. Here you are. So my aim now to find out minimal number of prime implicants which covers these 5 true midterms. How we can write this systematically, that's the question mark. So the rule is this. We are going to write a propositional algebra function. How I am going to write it? I am going to say what is the condition to cover this 0 true midterm. That condition I can explain it with a summation operation. If H and I prime implicants, if any of these prime implicants is chosen, then I can cover 0. Otherwise, I cannot cover the 0. So this this column tells me this, doesn't it? Because 0 is covered by H and I, not covered by the others. So in order to cover the 0 true midterm, I have got to choose either H or I. Because of that or, I put that or here. So this is a condition in order to cover 0 midterm. So this is just one condition. The second condition is cover this true midterm 1. So what is the condition cover this true midterm 1 is either G or H prime implicants should be chosen. G and I. That is the second condition. Third condition, how I can cover the midterm 4. Either F or H should be in. F or H. What is the condition for in order to cover 20 true midterm? Condition 1, 2, 3, 4 is E plus F. That means E or F. And the last one, 23, in order to cover the 23, the fifth condition tells me either D or E prime implicant should be in. So if we consider all these conditions now, if they are all true, that means each of them is 1, isn't it? Multiplication of all these ones gives me that function P. That means when this P function is equal to 1, all the midterms here are going to be covered. Because in order to cover to 0, I should have this, for 1 this, for 4 this, for 20 this, for 22 this. When all these conditions are correct at the same time, that means 1 at the same time, my function becomes 1, otherwise it becomes 0, that means condition is not true. So once we have found this function P here, this is in the form of product of sum. So if I transfer this function to sum of product form, what I end up with, if you see here EHI, if they are altogether true, that means 1 at the same time, I do not look at the others. I can say that P equal to 1. P equal to 1 is the condition that I am looking for. So this tells me when we choose the prime implicant E, H, and I, then all these true mean terms are covered. That was my aim, to find out minimal number of prime implicants which covers all the true mean terms which are not covered by essential prime implicants. That was my aim. So since all these product terms here, this one has got 3 element, this has got 3, this has got 3, this has got 3, and this has got 4. So this is not a product term that I'm going to deal with because it has got 4 terms in it. That means 4 prime implicants. I am looking for minimal number of prime implicants. So 3 is the minimal number here. So forget that. So in here we've got 3 variable included, 4 product terms. So they are all minimal number of prime implicants included here. If it were a 2 variable included product term, I was going to choose that one because 2 is less than 3, isn't it? So it becomes minimal. So in this case, I don't have 2, so I've got 3. So that minimal number for the prime implicants is 3. So if I choose these prime implicants, I can find one minimal function. So each product term gives me an alternative minimal function. How I am going to use it? Easy. In here, we said the function must consider essential prime implicants. So E and C are the essential prime implicants. They are all in these minimal functions. We know that. Now, from that conclusion, I found out that if I choose E, H, and I prime implicants, which is the minimal number of prime implicants which covers these true mean terms, put that E, H, I next to these essential prime implicants, I'll find out a minimal function. So for each product term, there is one minimal function here. So that means I found now all the prime implicants. We are saying this is a systematic approach. Why is that? You're going to write a P function by looking at this table, and then you're going to transfer this P function, which is in the form of product of sums. We are going to transfer it to sum of products form. When we transfer it to sum of products form, so it is easy to write these minimal functions, all the minimal functions. How we are going to transfer this form to this form? So it takes some time, of course. I'll show you one way of doing it. So if you look at this 2 now, H I times G I is equal. In Boolean algebra, we have seen that this is a distributive property in Boolean algebra, isn't it? So, for example, and these two can be transferred to F, H, and E, F. So the F's are common, so you can put F plus H and A. And the last one is D and E. So you're going to multiply this two, and then the result with this one, you're going to end up with this. So we transferred the product of sums to sum of products. the product which has minimal number of variables in it gives me the minimal number of prime implicants that I am going to choose. Now this takes time, but you can do it in computer, so there is no problem. But if you are doing it by hand, there is an alternative way of finding this resulting minimal function in a shorter time. So I'll show it this one in another example. So in this example, still I've got 5 variable function, but different function. Prime implicant table for this function is shown here. So already I taught how you can find a prime implicant table. I'm not going to repeat it here. After that, how we are going to choose the minimal prime implicants, that is the thing that I would like to teach you in here. So this 2 marked is the prime implicant. Because of that marked circled mark, this is prime implicant, essential prime implicant, sorry. Because of this, this is essential prime implicant. So there are 4 essential prime implicants. Essential prime implicant 1, essential prime implicant 2, essential prime implicant 4, and essential prime implicant, sorry, 3, essential prime implicant 4. So these are the essential prime implicants. So the question is, these essential prime implicants covers these marked true mean terms here. So what is not covered here is 10. Let me show it in different color. 10 is not covered, 11 is not covered, 18, 19 is not covered, and 26 is not covered. So these are the uncovered true mean terms. So what is left here, the number of prime implicants which does not cover, which should cover these true mean terms, this C, D, E, F, G, H. So altogether there are 7 prime implicants. So among these prime implicants, I am going to choose minimal number of those prime implicants which cover these 5 true mean terms. How I'm going to find that? The way is, that's the fast way. The previous one was a systematic way of finding it. Now this is a faster way. So the rule is this faster way. If a row covers another row, the covered row should be removed. Means covered prime implicants should be removed. Look at that G here and H here. H has got 1 in here. So this G row is covers this H row. So if I remove this, take this out, nothing would change, because when I consider prime implicant H, I am considering to cover 19. But if I consider G, G covers 11 and 19 together. So if I consider G, I do not have to consider H. So that's why I remove that. Look at this one, for example. D is covered by C, so I can remove this. Is there anyone? For example, F is covered by E, isn't it? So I removed covered rows from my table. So my table became, for example, that I also covered by G, so I removed the I as well. So when you remove these 4 rows, my table became as simpler. From that simpler table, I can easily see that C and E prime implicants covers all the true mean terms here. So C, that is C, which is this, and this. So I add these 2 prime implicants which cover all these true mean terms to my essential prime implicants to find out the minimal function. So you might ask now, so there are 2 methods, one of them is faster than the other one, so why we need the first one? So the answer is this. In the first one, we found all the prime implicants here, all the prime implicants, but in the faster method, I find only one minimal function. So that's the difference. If you need to find all the minimal functions, so the previous method, which is a bit longer by doing by hand, but it is systematic, choose that one. That is the end of this video then. So let's